All right, so let's talk about vision here. So I've already drawn this out, or at least tried to. And so what we've got is what's going on when it's dark outside. Okay, so I can write this step by step as we walk through it. So when it's dark, rhodopsin is inactive. Okay, so whoops, that doesn't work either. So rhodopsin is inactive. So as a result, we've got an inactive G protein, and that G protein is transducin. We know it's inactive because GDP is attached to it. As a result, PDE, which is that enzyme hammer thing, is inactive as well. We need to basically turn it on, but we don't have the stimulus for it. And so what happens is cGMP is hanging out over here, and it's the key for this sodium channel. And so sodium goes from outside to inside, and that leads to a few things. And so we have sodium influx, and there's also calcium, but we're just focusing on sodium, leads to depolarization. Okay. This depolarization causes glutamate release, but onto bipolar cells. And this ultimately inhibits bipolar cells. Okay, which means they don't activate ganglion cells, which means that we don't have an action potential along the optic nerve. Okay, so we're going to talk about now what happens when light hits rhodopsin here. So we're going to change this. So instead of saying dark, it's going to say light. Okay, so we're going to say light hits. Okay, so that's step one. And so what that does is that causes step two, which is now we have retinol plus opsin. Okay, when we have retinol and opsin, that leads to step three. And so step three is right here. And so what happens is GDP leaves, and GTP, which is just floating around in the cell, comes and binds there. Okay, so now GTP is attached to the alpha. All right, so I'm going to leave three there. And so then what's next is that GTP and alpha, so this is step four, come and they bind to PDE. And what that does is that activates PDE. Okay, so let's go to my red here. And so now we've got, we'll put step five. So now we've got my little hammer. And that is going to take cGMP, and turn it into GMP. Okay, and so as a result, get rid of this little C here. Okay, we have GMP. All right, that's step five. And so what happens next, and I'm not going to redraw everything here, but this gate becomes closed. Okay, and so as a result, sodium's not able to go in. We're going to get rid of this. There's still sodium in the cell, but there's not as much. And so what happens is sodium's not able to go in, so it just goes boing. Okay, and so that leads to hyperpolarization of the cell. Okay, so let's kind of walk through this in steps here and just write what happens. So we'll do it in this color here. So step one, light hits rhodopsin. Rhodopsin becomes retinol plus opsin. So when opsin is available, so opsin allows GDP to leave, GTP to enter. Okay? And by enter, I mean bind with alpha. So GTP and alpha bind to PDE, which turns on PDE. PDE breaks the key, which is cyclic GMP. So then those cGMP gated sodium channels close because we don't have the key anymore. This leads to hyperpolarization. Which leads to reduced glutamate release. Okay, I don't have room to write it here, I don't think. Actually, we can do it this way. View, we'll just do seamless here. So we're gonna scroll up just a little bit. We'll zoom out a little bit. Okay, and so then this leads to increased activation of bipolar cells. Okay, allows them to become depolarized, which leads to increased activation of ganglion cells, which leads to increased optic nerve action potentials. And your brain goes, hey, I see something. And so that is how vision works. So real quick though, I just want you to go back to how we talked about a G protein normally happening. Okay, so we had G protein, so a hormone binds to a receptor. So in this case, we don't have a hormone, but we have a light activating a receptor. So light activates the receptor, which is rhodopsin. As a result, that activates the G protein, and the G protein is transducin right here. Okay, and so in order to activate it, we get rid of the GDP and we bring in a GTP. And just like we talked about, GTP and alpha leave, they go and bind to a protein. In this case, that protein is PDE right here, okay? And as a protein slash enzyme, what happens is PDE, in this case, breaks down cyclic GMP, so that used to say cyclic GMP, and so now we've got GMP, which closes these doors right here, so sodium can't go in, and so that causes that hyperpolarization, okay? So this is very similar to what we talked about when we first started talking about G proteins.